Hello folks, this is 2024 October-November, paper 4.2, and the question number is 1. This question is concerned with the chapter circular motion and electromagnetic induction as well, let's say magnetic field. It says a metal wheel consists of an axle A with 8 spokes here, and a rim as shown in figure 1.1. Point X is on the rim at the end of one of the spokes. The rim has a radius of 0.85 meters, so I name it as a small r. The wheel is rotating clockwise with an angular velocity, angular speed of this is omega equal to, and it says clockwise, it's a clockwise, so it is rotating like this, and I can say it like this. Now, for point X, determine the speed. So we have to find the speed here. So V is equal to omega into R, equal to omega given here as 140 and R given as 0.85. So it should be equal to 140 into 0.85 equal to 119. So it's equal to 119 meter per second. So 119 meter per second. Then we have to find the centripetal acceleration. So this A is equal to omega square into R. So it should be equal to omega is 140 square into 0.85. So it should be equal to 140 squared into 0.85. So this will be 16,660. So 16,660, I can write it as a 16700. So 16700 meter per second squared. Now, not much of difficulty here. So now comes, like this. So there is a uniform magnetic field of flux density 0.18 Tesla into the plane of the page. So now we have a magnetic field of 0.18 Tesla into the page. So that means the magnetic field is going like this. So if I use a Fleming's law, it should be this finger, this finger should go like this. So if I apply some laws, this finger should go like this. So, and this is equal to 0.18 Tesla. So this thing is equal to B. Now, state Lenz law of electromagnetic induction. So it says that the direction of EMF is such that it opposes whatever change that happened there. It opposes the cause of that whole phenomenon. Right? The direction of the EMF is to oppose the cause, whatever has caused that thing. So that is Lenz law. So I'm not focused much about this. Now, show that the time taken for point X to complete one revolution is this much. This is the time period. So time period is equal to twice pi by omega, equal to twice pi by omega was 140 equal to, so it is 2 into shift pi divided 140 equal to this much. So we have to do it like this. So it is 0.044879 and so on. So let me write as 0.488 seconds equal to 44.88 millisecond, nearly equal to 45 millisecond. So the answer is there. Now calculate the magnetic flux cut by the spoke AX during one revolution. So when it rotates once, we have to find the magnetic field flux cut by this thing. So from here to here, field lines are going like this. So we have to find the field lines cut. So that is equal to, so we have to find phi here. So that phi should be equal to B into area cover. So when it covers one rotation, the area cover will be equal to the area of the circle, pi r square. So it should be equal to phi into area equal to B into pi r squared equal to B is 0.18 into pi is pi into this R is, the R was given as 0.85. So it is 0.85 squared equal to, so 0.18 into shift pi into 0.85 squared equal to like this. So it is 0.40856 and so on. So that's equal to, I can say 0.4141, 0.41, and its SI unit is Weber, which is we write as WB. Now, determine the magnitude of the EMF induced across spoke AX. So the value of EMF is equal to phi by T. So change of phi will be this much. In one rotation, the flux will change by this much. AX will face this much of flux change. So it is 0.40856 by the time is equal to time period which is given here, which was 0.04488 equal to. So we should have this divided 0.04488 equal to. So this is 9.1. So it is 9.10348 volt, 9.1 volt when I write 2SF only. Now, use a Lenz law to explain whether the potential is higher at NA or NX of the spoke. NA or NX of the spoke. So what we have now is, right now this thing is moving in this direction. Now according to Lenz law, the EMF should be such that it has to induce current in such a way that the force should be like this. So this is the direction of the force it should produce. So that means now when I apply the left hand rule like this, so I have the direction of the field line like this. This is the direction of the field line, this. And the force should be like this, So this means current should be flowing in this direction, which means the current should be from A to X. So see here, force in this direction, this F, magnetic field line here, the current should be flowing in this direction. This means it should be going from here to here. So that's why, let me write here, force on X should be reverse compared to its present direction of movement. So from left hand rule, current should be from A to X. So this means since current flows from higher potential to lower potential, A should be at the higher potential. According to the conventional current direction. This is according to the conventional direction of current. So A should be at the higher potential and X should be at the lower potential. So that's the answer to this question.